to me? I mean, let's just talk about what happens. What's the first thing? What's the first thing that's going to happen? Huh? The action potential is going to go down to axon, right? Okay. What's the next thing? What does that action potential cause? The calcium channels are going to open up. Now calcium's going to move in. Why is calcium going to move in? Do we have more calcium outside the cell or inside? Outside. So the same with like the sodium, you have more calcium outside and also the charge also. So, okay, so calcium's going to move into that synaptic bulb. Then, what's going to happen? It's going to trigger exocytosis, allow the fusion of the vesicles that contain the acetylcholine.
With regards to calcium, is calcium coming into the nerve like farther up and on the axon, or only there at the end?
At the end.
It's a specific channel for
Yes.
calcium?
Okay. And then in this case, you're talking about the sarcoplasmic reticulum, which is full of calcium, right? Okay? So now, you have that. Now what happens? Yeah? So the acetylcholine binds to the ligand-gated channel. And what does that do? Opens it up so sodium can rush in. Potassium can go out too. You know, it's leaky for potassium. But why wouldn't as much potassium go out as sodium comes in?
Membrane potential? The difference in the voltage between the inside
So
and
voltage, probably a big one, because you have that negative on the inside, positive on the outside. Even though you do have less potassium on the outside, you still have more negatives on the inside. And also, okay, so let's see, now what happens?
So, clarification, that sodium coming in causes the cell to reach threshold.
Exactly. So the sodium comes in because you have a negative on the inside, right? And when the sodium has a positive charge, it's going to cause it to reach threshold, which is going to cause what? Action potential. This. Okay? Then what's going to happen?
action potential has T2.
Okay, it's going to move down the T tubules, right? It's going to move along that plasma membrane. It's going to go down the T tubules. Then what is that action potential going to cause? Huh? Calcium release again from that sarcoplasmic reticulum. Okay, so we're going to release calcium again into the sarcoplasm, right? So we have different names, but it's the same as the cytoplasm, but it's just in muscle, right? So release this calcium, and what does the calcium do in the sarcoplasm? Huh? Binds to troponin, and then what does that do?
Exposes the active sites.
It exposes those active sites. So then, what happens? Connect, right? It's going to connect. Okay, so let's talk a little bit about that myosin head. So the myosin head is in what formation when it connects?
Well, I'm just saying, I know it has to be cocked back.
Right,
But
it's in the high energy state.
Okay.
Okay, so that's exactly what I was saying that over again, I'm sorry. Okay, so it has to be in the high energy state, so right, it connects to the actin, and then it's going to release its ADP and phosphate, right, and then it's going to go back into its low energy. So when it does that, it moves down the actin, right? So to be able to disconnect these, you're going to have another ATP come in and disconnect them, right? Then you're going to have another ATP to energize that myosin, and it can keep going down and down until what has to happen?
Where the enzyme comes in to stop it.
Right.
SSQ4 necessary.
Yeah, acetylcholinesterase. Has to take that acetylcholine off that ligand-gated channel up in that synaptic cleft, and then that channel can close, and then you can stop. And then, what else has to happen? Calcium has to be pumped back. Okay? Does that make sense? Did this help at all? Talking about it, because when I talk around, I can see a lot of confusion. So, okay. So then the next part was, what are the 3 factors that affect muscle tension? Well, what's going to help us get greater tension?
Greater weight or
Recruitment, right? Greater recruitment?
Synonymous with just greater stimulus.
Greater stimulus, that if you, faster stimulus, right? Okay. Anything else that you guys
Is that different than recruitment, though, or can we say this is the same thing?
Well, recruitment would be recruiting, but then how fast it comes in is important. You know, if it comes in faster. So, frequency. So, recruitment and then the frequency also. Okay? Okay, so then the ATP. Where's the ATP coming from? And yes, it's right on the board there. Okay, so your first initial is from that phosphagen system. The phosphagen system, which is taking that hydrolysis of that creatine phosphate. So remember, when you guys go buy all those the health food store and they're selling that stuff, that's what they're trying to sell, right? And then, so after that, for like 2 minutes, glycolysis, which is going to take glucose and turn it into ATP, right? Break it down. And then also when you do that glycolysis, you make 2-pyruvate, which is going to go into that Krebs cycle, and the